Hi, and this is section 7.4. We can start on page 451, and this section is entitled Solving Linear Systems by Multiplication First. And again, I should probably just write the page number up here. This section, I guess we could look at, section 7.3 and 7.4 are both over elimination. And one question that always comes up is the following. If you take a look at page, let's just actually turn ahead for a minute and look at page 454 and look at problem 6. We want to solve this system using elimination, but when you look at the system carefully, and please look at page 454, question 6, do you notice how when you want to eliminate these, there's nothing to eliminate, because if we try adding, the x's won't eliminate, nor the y's, and if we try subtracting, it's the same thing. The problem isn't set up to eliminate right now because we don't have a variable that will eliminate by either adding or subtracting. People always ask, well, what do? We can't eliminate. You can eliminate, but there's a couple things we'd have to do first, okay? So here would be the process to using elimination if right at the beginning of the problem there's nothing to eliminate, okay? Step 1, as we did the other day, make sure first of all that both equations are in standard form, because if it's not in standard form, we're already going to have a problem. So make sure, in this case, they are. Step 2, find a variable to eliminate. Now you notice we already talked about this. There's nothing that we can eliminate right now. If we add or subtract these equations, you're still going to have x's and y's. Easy to fix. I put this in green. Do you notice nothing will eliminate? We need to pick one equation and multiply that equation to create an elimination. So you might be like, what the heck, Mr. Lemansky, are you talking about? Very simple. Look at the second equation. Do you notice if I multiplied this second equation, if I multiplied everything by 5, you would get negative 10x here? Well, if you have negative 10x and we have positive 10x here, we could add these equations and the x's would eliminate. So that's what I'm going to do. I'm going to multiply, put a little m5 here. I put m5 next to the second equation to show you that I'm going to multiply everything here by 5. So here's what I did in that next step. This is equation A. Here's equation B. Equation A didn't change. Equation B, I multiplied everything by 5. So I get negative 10x plus 15y equals 50. Now I can eliminate. If I add these up, and I'll do that on the next slide, the 10x and the negative 10x will eliminate each other. Okay, so let's go to that next slide and take a look at that. I eliminated the x's by, right here, I'm adding to eliminate the x's. And negative 9y plus 15y is 6y. 46 plus 50 is 96. I can divide by 6 and I get y equals 16. So I know my answer is, remember, I know right now my answer is some x value comma 16. All you need to do to find that x value is take 16 for y, replace it in one of your equations. I replaced it in my first equation, and I have 10x minus 9 times 16 is 144 equals 46. I can add 144 to each side. I can divide each side by 10, and I just figured out that x is 19, so I get the point 1916. And remember, once I do that, I ought to check it. I can go back to the beginning of the problem. I can plug in 19 and 16 here and make sure it works. I can do the same thing here and make sure it works and check it. Okay? So that's how we can eliminate even if the problem isn't set up to eliminate. That's why they call this section, if I go back to the title, they call this section using multiplication to set up elimination. I had to multiply the second equation to set up an elimination. Okay? Let's do another one. I think just working through a few would be the best thing to do. I'll jump ahead. Let's look at number 8. And in question number 8, we have 11x minus 20y equals 28, and 3x minus or plus 4y, I should say. 3x plus 4y equals 36. All right, so I want to eliminate. And as I look at this carefully, I'm like, wow, there's nothing, I can't add or subtract and get anything to eliminate. I got to multiply an equation to set up an elimination. So as I look at this carefully, I notice, wait a minute. If I take 4y and multiply this by 5, I get 20y. And negative 20y plus 20y would eliminate. So I'm going to multiply the second equation by 5. Now, it's just a coincidence, I got to make that clear, that I happen to multiply by 5 on these first two problems. Just a coincidence, I'm not always going to multiply by 5. So equation A didn't change. It's still 11x minus 20y equals 28. Equation B, when I multiply everything by 5, I get 15x plus 20y equals 180. Now I can add to eliminate, so I'm going to write add. 11x plus 15x is 26x. These y's eliminate. 28 plus 180 is 208. I divide by 26, and I just figured out x is 8. So now that I know x is 8, I got to find y. So I decided to take 8, plug it into my original equation. I get 24 plus the 4y equals 36. I'm going to take away the 24 from each side. 4y equals 12. I can divide each side, of course, by 4. And I just figured out that y would equal 3. Actually, I should erase that out of there. Y equals 3. Okay? So I divided each side by 4, and I got y equals 3 in this case. I'm going to actually write that out better so you can see it better. Divided each side by 4, y equals 3. Okay, so I had 8, 3, and then I need to check it. So, of course, I can take 8 here and 3 here. 88 minus 60 is definitely 28. 8 and 3 work here. 24 plus 12 is 36. Do another one here. All right, now in this one, as I look here, I'm like, well, geez, okay, nothing's eliminating if I add or subtract, and, well, to get 9, I'd have to multiply by 4.5. That, I don't know if I want to multiply and make decimals, and, well, 3 times what's 8? It's going to be decimals. Sometimes it's easier to multiply both equations to get an elimination instead of working with fractions and decimals. So that's what I did here. I was like, okay, multiplying by 2 by a number, a whole number, doesn't give me 9. Multiplying 3 by a whole number doesn't give me 8. But here's what I could do. If I take the first equation and multiply by 2, I get 18x. And if I take the bottom equation and multiply by 9, I get 18x. And that's an easy elimination. So that's what I'm going to do. I'll multiply equation A by 2. And when I do that, I get 18x minus 16y equals 8. And then I'm going to multiply equation B by 9. That gives me 18x minus 27y equals negative 36. Now I have an elimination of x's if I subtract. I'm going to subtract, so you've got to be careful when you subtract here. 18x minus 18x eliminates, but here's where you got to be real careful. We have negative 16y minus negative 27y. So think about that. I'm going to write on the board here what I just did. I did negative 16y minus negative 27y. Well, remember, add the opposite. That's actually 11y. And 8 minus negative 36, 8 minus negative 36, that's add the opposite. That's actually 44. So now I can divide by 11. I got y equals 4. And if y equals 4, now I can find x. I can find x by plugging in 4 for y, which would give me 2x minus 12 equals negative 4. Add 12 to each side, 2x equals 8. Divide by 2 on each side. Divide by 2 on each side. And I got x equals 4. My solution is 4, 4, and I should check it. If I plug in 4 and 4 here, I have 36 minus 32, which equals 4. That checks out. And if I plug in 4 here and 4 here, I have 8 minus 12. That equals negative 4. That checks out. So this is definitely the correct response. Let's do one last one here just to make sure we got this down. Number 14, I want to eliminate. And as I notice, if I'm going to multiply just one equation, 8 times, well, 1.5 gives me 12, but if I multiply by 1.5, that's going to give me fractions. Most of you don't like that, or decimals. What do I multiply 7 by to give me 11? That's not working out well. What I could do is multiply both equations. I noticed right away that if I take 12 times 2, I get 24. And if I take negative 8 times 3, I get negative 24. So I'll multiply equation A by 2, which gives me 24x minus 14y equals negative 4. Multiplied everything by 2. I'll multiply the bottom equation by 3. Negative 24x plus 33y equals 42. Now I can eliminate if I add. 24 plus negative 24 is nothing. Negative 14y plus 33y is 19y. Negative 4 plus 42 is 38. Divide by 19 on each side, and I get y equals 2. Now that I know that y equals 2, I can replace 2 or substitute 2 in for y. I get 12x minus 14 equals negative 2. I added 14 to each side, which gives me 12x equals 12. I divide each side by 12, and I just found out x is 1. So my ordered pair is 1, 2. And I can check that now. I'll check 1, 2 and see if that's a solution. If I put a 1 in here and a 2 in here, I get 12 minus 14 equals negative 2. That works. If I plug in a 1 here and a 2 here, I get negative 8 plus 22. That does equal 14. That's definitely a solution. So again, when you do these problems, a couple reminders. I didn't work out an example where both equations were not, either equation was not in standard form. You got to make sure both equations are in standard form first. When I look at a problem like trying to see if there's something like that in the bookwork. I don't know if there is or not. But yes, 23 in the bookwork on page 455. You notice how the second equation is not written in standard form. You have to rewrite that second equation in standard form before you do anything else. So make sure they're both in standard form. Pick a variable to eliminate. If it won't eliminate naturally, multiply either one or both of the equations by a number to create an elimination, solve, and check. Okay? That ends my video. If you have questions, we can go over more in class tomorrow.